All right, in the last lesson, we looked at basically civilization and body symmetry, and then we went on to look at your tissue layers. And we concluded that organisms either are asymmetrical, radial symmetry, or bilateral symmetry. Asymmetrical meaning you can cut it from any plane longitudinally, it will not produce two identical halves. Radial symmetry, you can cut it from any plane and it will produce two identical halves. And then bilateral symmetry, which is us, you can only cut it from one plane longitudinally and it will produce two identical halves. And then we looked at tissue layers or your germ layers. Basically, what are tissue layers? Your germ layers are the first tissue that is formed from an embryo uh, of any organism. And then organisms can either form two germ layers only, which are known as diploblastic organisms, or they can form all three. Ne? The first primary, which is ectoderm, mesoderm, and then the secondary germ layer, which is no, the ectoderm and endoderm. Then the secondary one being your mesoderm, which gives rise to reproductive organs, your connective tissue, and lymphatic system. So basically, those are your triploblastic organisms. Today, however, we're gonna move slightly from those ones, and we're gonna do the third body plan. Basically, your gut or openings, the gut. The openings. How many openings does an organism have? So we're going to be looking at how many openings. If an organism has one only, one opening only, it is known as an organism with a blind gut. Does not mean the organism is blind. And then if it has two openings, it is known as an organism that has a through gut. Through gut. So basically, this is what we're going to be looking at today. Right? Let's go back to our slides. Right. So an organism that only has or only has one opening, for example, your hydras, for example, basically those are known as your blind gut organisms. Then good. Animals with only one opening will consume food through that one opening and excrete food in that one opening. So imagine this: you yourself as a human being, if you had one opening, you basically taken food from your mouth and then basically use that one opening, which is your mouth, as an anus, basically, to discard the food. So you'd be having a blind gut. Fortunately for us, we do not have. This limits the amount of food that these organisms can consume because they must excrete. So basically, at some point, they must consume food. You must eat. And then at some point, you must excrete. So you cannot eat and excrete. It's like wanting to poop and eat at the same time. We humans can do that. You can sit on a toilet seat and then eat while passing out your feces. It can happen. It's physically possible, but for these organisms, it's physically impossible because they have one opening, and that's they use that opening as a mouth and as an anus, basically. Good. So animals basically that have two openings are known as organisms that have a through gut. A through gut is an advantage because food can be consumed continuously because it moves through the digestive system up until it exits via the anus. Sections of the digestive system can also be specialized, for example, to improve the efficiency of the digestive system. So in actual sense, most organisms, if not all, that have a blind gut are basically diploplastic. Ne? They're diploplastic. And then these one are triploplastic. They're specialized organs. Ne? Good. So that is basically blind gut and through gut. Nothing much to it actually. And then let's move to your body cavity, your body cavities. Your body cavities, which is the last one. So this lesson is gonna be fairly short. The last one will be basically your body cavity, body cavities, aka your sulum. So when I mention the word sulum, just know I am talking about a body cavity. What is a cavity? Space. Space inside your body. Ne? Good. There are three types. One, an organism can have what we call a pseudo. Pseudo means false. So it can be a pseudo or have a pseudo-sulum. Those are known as pseudo-sulumates. An organism now can have no sulum, no body cavity at all. Think your flatworms have no body cavity. That is an asulomate. Those are asulamates. And then the ones that have true body cavity, sulomates. They are known as sulomates. So let's get into it. Let's see what is the difference between the three that we have just. Oh, technology, the death of me. Stay there by the corner. Good. So let's start. A sulum is basically a body cavity, a space, the space that develops inside the mesoderm tissue layer in more advanced animals. Yeah? So animals without a sulum basically are known as a sulumate. So for you to have a sulum, you must have a mesoderm. That means that organism must be triploplastic. Yeah? Asulamates are animals that do not have a body cavity. Asulomate animals or organisms may be either diploplastic or triploplastic. So it is possible for them to be triploplastic. Asulomate animals are usually smaller and are less mobile than your sulomates. Ne? Good. A good one would be your flatworm. Flatworm is an asulomate. If you look at it, the outer layer body covering is the ectoderm, and then the tissue-filled region, then the endoderm. So, and then in the middle, it has your mesoderm. But this mesoderm does not allow it to have a sulum. So it is an asulomate. Then your sulumate organisms that have a true body cavity or a sulum in their mesodermal tissue layer. However, some triploplastic organisms have a body cavity that is not surrounded by a mesoderm. These are known as pseudo-sulomates, right? So those ones what are pseudo-sulomates? Organisms that have a body cavity, but the body cavity does not have a mesoderm covering it. Those are known as a sulomate. So let's look at a pseudo-sulomate. Pseudo-sulomate is an organism with a body cavity that is not derived from the mesoderm, right? Good. And then what are the advantages of having a sulum? Because the main thing that we're looking at here is having a sulum, the space inside inside the body allows for more complex organs to develop, such as the digestive organs and muscular system and blood system. Yeah? That's the first one. Then secondly, it allows for the creation of hydrostatic force to be generated for movement of soft-bodied organisms. So what do we mean? Look at what are organisms that have a hydrostatic skeleton. For example, those are your earthworms. So it allows for hydrostatic pressure and force to be generated so that they can use their hydrostatic skeleton to move. Good. Then it also separates the endoderm and the ectoderm from each other with a cavity which allows the layers to move independently of each other. This allows what we call peristalsis to occur, right? Remember peristalsis from the digestive system you did in grade 9, right? Then in some organisms, the coelomic fluid found inside the coelom obviously helps to transport nutrients and waste. So that is the advantages of having a coelom as an organism. Activity 2. Let's get into it. Study the diagrams below and answer the questions that follow. 1. Which diagram, A, B, or C, represents a coelomate, and a pseudocoelomate? Number 2. Which diagram represents the most advanced organism? What advantages does a coelom give to an animal? Let's go into it. Which organisms, A, B, or C, represents a pseudocoelomate? Let's look at a pseudocoelomate. So here's the body cavity in pink, but the body cavity must be covered by a mesoderm. Where's our mesoderm? Mesoderm is present at A, B, or C. So because the body cavity is outside of the mesoderm, so that would be C. So mesoderm is present, however, the body cavity is not covered by the mesoderm, that is C. Then a coelomate, A, because it does not contain a body cavity, and then a coelomate will be B because it is situated between the mesoderm. If you look at it, here's the mesoderm, and then the body cavity. Here's the mesoderm and the body cavity. This body cavity space here, remember the mesoderm is in green. So here's a mesoderm on the inner part and mesoderm on the outer part of the coelom. But when you look at C, there is a mesoderm, yeah, but only covering the outermost part of the body cavity, which is this pink part over here. The inner part is not covered by the mesoderm, so that makes it a pseudocoelomate. All right, which diagram represents an organism with the most advanced? That will be your coelomate, and then it's going to be B. What advantages can a coelom give? Basically, we just did them right now, and that is why your answer for number 2 had to be B, an organism with a coelom, because it allows for complex development of organs such as the digestive organs, muscular system, and blood system, basically. So that's why that's the advantages of having a coelom. Right, that is the end of it. And then next lesson, now we get into the different phylums and look and basically compare them using the body plans that we just did.